All axes are representing some sort of depth. Everything recedes. X-axis is a radial. My y-axis is a radial. My z-axis is a radial. At this point, it really doesn't matter what you call these things, but it is essential to maintain their own identity. And when composing in space, to not get mixed up of which plane of our cubic volume corresponds with which dimension. So this form, if we take their ecliptic boundary, it is a tetrahedron. Again, this beautiful platonic solid composed of equilateral triangles. Here I'm going to express 3 more cubes existing in perspective. And it's always composed of 3 lines from each dimension. Let's call this one Z. We've got 1, 2, 3 Z lines. Let's call this one X. We've got 1, 2, 3 X lines. Let's call this one Y. We've got 1, 2, 3 Y lines. And now we can see this cubic volume taking form. Now let's create another on top of it and below it. And now I will remove any line that contradicts this story so as to give the viewer a clearer sense of the space being put forth. Here, and I'll even erase in a fashion that is organized with my perspective grid. So now I'm just shading my X and Z convergent plane with Y-axis lines. And now you can see, let's take this cube. I've got an X set of lines and a Y set of lines. Now this one, we've got a Z set of lines and a Y set of lines. And then this plane here is comprised of Z and X. Here they're very flat, so it's hard to tell sometimes the difference, but as long as you understand which axes are receding to which dimensional apex, you'll have that sense of constant volume. I love 3-point perspective.